Tango Delta.
Touchdown confirmed. Lunar Legion safely on the surface of Moon, ready to begin seeking the signs of past life.
Artifacts on the Moon range in many different sizes, minuscule like powder, to huge like the rock. Some rocks. Scientists need to gather data and study these objects to study the Moon as much as possible. That's why ensuring such data can be collected and transported easily is imperative. But why do all this? What's the point? Exploring the Moon prepares us for exploring deep space, such as missions to Mars and beyond. Moreover, it helps with learning more about the early history of our solar system and the processes that shaped it. However, humans can encounter many risks when exploring the Moon's surface. AI automated rovers can overcome them.
Nominal. The Lunar Legion has started traversing the surface to begin exploration.
NASA's Navigation Doppler LiDAR instrument, mounted to the front of the rover, maps the Moon's surface in 3D. By emitting infrared lasers 10 times per second, it's able to accurately map the environment. The AI uses this information to navigate the rover through a path that avoids hazards and obstacles. Here is a demonstration of what that looks like. Hit the rough terrain on the Moon. Good stability is mandatory. The Legion employs the rocker bogie system, which is the same suspension type used by NASA's Perseverance Mars rover and ISRO's Pragyan lunar rover. The principle of the system is that the Legion can keep all of its 6 wheels in contact with the surface while scaling challenging obstacles. Even when driving on severely uneven terrain, it's able to maintain stability. For extra support to avoid slips or sticks on loose soil, there are aluminum wheels with grousers supported by curved titanium spokes. This is the dual tool arm system. And this is the claw arm system, the Legion's main components for gathering artifact samples on the Moon. Once the AI-modified Panoramic Mastcam Z identifies a specific artifact that matches references from its scientific database, it proceeds to sample collection. Using AI logical inferences, it can identify the appropriate tool to use based on the size of the artifact. For large objects, the rover extends its left arm, using the claw to grasp the object before putting it into a titanium storage compartment at the rover center. For smaller artifacts or powdered samples, the rover engages the dual tool system on its right arm. This system includes a drill, which can rotate to face downward and break the artifact down. After reducing the size, the arm rotates to bring the scooper down, which collects and deposits a sample into the storage compartment. Utilizing NASA's Alpha X spectrometer part of the camera system, it can analyze the chemical composition of each artifact. Additionally, the IR sensors on the front and sides are used for temperature measurement. NASA reports of extreme temperatures on the Moon, spiking to 121 degrees Celsius in the daylight and then plummeting to minus 133 degrees Celsius after nightfall. For that reason, these temperatures should be monitored daily using the Kientz FT thermal infrared sensor. When the rover reaches areas of the moon that lack sunlight, the emollient SR-32 battery-powered flashlight will light up to see in the dark, producing up to 120,000 lumens. Speaking of batteries, there are two Eagle Pitcher 28-volt lithium-ion batteries installed in the rear end of the rover. When there's sunlight, the solar panels will reach the batteries. When there's periods of darkness, however, the multi-mission radioisotope thermoelectric generator, or MMRTG, will. Now, all this scientific data needs to be sent back to Earth. The UHF antenna is primarily used to send large amounts of scientific data through relay satellites to the deep space satellite receivers on Earth. Finally, the brains behind the Lunar Legion is the AI, fully powered by a beast of a microprocessor, the IBM PowerPC 750. Hopefully, the Lunar Legion will be sent out to the moon one day, paving the way for advanced deep space exploration.